we're going to study measures of variation. Okay? The most important one that we're going to use is called the standard deviation. So that's what I'm going to try and get across. What exactly that is. It's a number associated with a sample, because it's a statistic. By the way, the symbol for the standard deviation is going to be a lowercase s. A lowercase s. Just like x bar is going to be the center of the data. Should I zoom in a little bit for you guys in the back? I'm seeing some squinting. That help a little bit? Okay. So what I was saying was, we want to understand what this number is really measuring. Okay? And so here's where I thought a couple of different data sets might help us, right? And so we have x minus x bar. Well, not yet. We have x. I'll put that on this column. And so again, my x's were 9, 10, 11, 12, 12, 13, 14, and 15. And now, why am I subtracting the mean? Well, because when we say deviation, what we're really meaning here is, how about distance away? That's kind of what deviation means. Distance away from what? From the mean. Right? So when I go to here and like when I'm at 12 and I'm in the column now x minus x bar, what's that going to be? How far away from the mean is that? Anyone? 0, right? 12 minus 12 is 0. Whereas if I'm at 13 minus 12, I'm going to be at what? 1. If I'm at 14 minus 12, I'm going to be at 2. Of course, but up here, if I'm at 11 minus 12, I get negative 1, right? I get negative 2, and I get negative 3, and I guess down here I get positive 3. Does that make sense to you guys? Hey, what I'd like to also do is I'd like to take the second data set, B, which was a bunch of 12s. I don't know how many I had. Let me count them up. This one. There's A. What did I say for B? Oh, just 5 12s. Okay. So let's look at that. Let's play the same game. Here's x, and here's x minus x bar. And suppose I have a whole bunch of 12s. Well then, what's going to happen when you have a whole bunch of x minus x bars? Those are all 0. And so what happens is, our computation is going to eventually show that this set, there is no deviation from the mean. The standard deviation of this set is going to be 0. Okay? Now, I don't see that yet, because I haven't shown you the complete formula. I mean, the complete formula, and by the way, there's a nice little pull-out card that comes with the book. I wonder if I can show it to you. Yeah, I guess I can. You may or may not have this. I have extra copies I can get you for quizzes and things. Really, the formulas kind of come into play in chapter 3, but you see this? Wow. Yeah, this is an extra pull-out card. So what they did was they took stuff from lots of pages. Like here. Here's all the formulas they think you're going to need for chapter 4. And here's all the formulas they think you're going to need for chapter 5. Don't we have something for chapter 3? Well, I don't see anything for chapter 3. But I will tell you this. The formula for standard deviation of a sample. You found it on the card? It's given by the following. You people that see it, what do you have? S equals what? Can you read it? This big formula? It's a big square root, right? Of what? Do you remember what this letter is right here? That means sum. It's a capital sigma. It means you're going to add up a bunch of things. What is it that we add? Don't we add in parentheses x minus x bar squared, right? And then the formula says we have to divide also. What do we have to divide by? N minus 1. Okay. I'm trying to help you guys make sense of what I think is a complicated formula. Thankfully, you won't have to use that formula because our technology can compute this. Okay? And yet, I'm going through it in slow motion today because otherwise you're not learning what this really does for you. Okay? So you'll notice I have a bunch of x minus x bars, and I'm seeing that some of the numbers are farther away from 12 in the first set, but in the second set, nothing deviates from 12. Does that make sense to you guys? Okay. Now, here's a question. Why do I have another column where I square these things? And the answer is this. What would happen right now if I added all of the things I have in the column, the deviations? Well, if you added these all up, you'd clearly get 0. Right? But what would happen if you added all these up? You'd get 0. But which data set is more spread out, A or B? A is clearly more spread out. They shouldn't have the same standard deviation. And so what we do is we square all the differences. Why? Because when you square a negative number, what happens to it? It becomes positive. And so what we add is not just x minus x bar, we add the x minus x bar squared. Let's see how this works. When I square each of these, let's see what I get. I get, well, 9, 4, 1, 0, 0, 1, 4, and 9. Correct? Does this make sense to you guys? Okay. Over here, I guess if I did x minus x bar squared, I still get all zeros. Okay. So what's the next step, guys? Add them up. Well, I'll do that very quickly. 9 plus 1 is 10, plus 4 is 14. And then I have another 14 up here, so if I add them up, I get 28. What do I divide by? Yeah, now that's kind of interesting. Because you might expect we would divide by n to get the average number, right? Usually divide by the sample size. For technical reasons, statisticians divide by n minus 1. I'll just leave it at that. So what are we dividing by in this first example? 7. 28 divided by 7. And then we're going to take the square root. So we're going to say s equals the square root of 4. And so what's the standard deviation of this very first data set? 2, whatever that means. You could play the same game down here. You could say s equals, and you would get the square root of 0 over 4. But what's 0 over 4? What's the square root of 0? 0. And so you get no deviation from the mean. Are you with me on this? So now you guys have Excel launched. And I think a good exercise for us would be the following. I'd like to take Excel and just type the data in to a column. And we did this yesterday, right? So maybe what I'll do is I'll label this column X, and I'll go ahead and type in my 9, 10, 11, 12, 12, 13, 14, and 15. And then I'm going to label this one x minus x bar. I mean, you could decide how you want to label it. It's hard to read that anyways. Maybe I can zoom in for you guys. Might be smart. Let's make the font a lot bigger. We might have to go even bigger.
You should be able to just go down to the bottom right where it's
Yeah, I guess. Okay. Thank you. That's probably a better move. Then we can get everyone in. Okay? That's a better move. Thank you, Jamie. So, yeah, I said x minus, maybe I'll say x minus mean. You know? Meme. My problem is I can't see my screen. Okay. So what I wanted to show you is how Excel can be used, and some of you have used spreadsheets for years, but some of you haven't. And so I'm just going to, show you that if you ever want to type a formula into Excel, or actually do any mathematics, you start off by typing an equal sign. So I'm going to type an equal sign. So I'm in the square next to the 9, and I type an equal sign. And what I want to do is I want to subtract 12 from 9, right? So I can do this. I can say it equals this, A2, minus how much? Well, minus 12. Because 12 was the mean. Oh, yeah. What did I do with that font? That's awful. Okay, now you can see again. You guys follow? So again, let me show you what it was I did. I was here, and if you want to see what's typed there, I typed in equals. I clicked on A2. You could also type A2 to point to that cell, minus 12. So what I want to do now is this. I'd like to go here. I'm going to right-click on that square, and I'm going to do copy. And what you can do in Excel is you can copy a formula to another square, but the spreadsheet is smart. It tries to anticipate what you really want to do. You see, what I want to do, bless you, I want to subtract 12 from each of these entries, right? And so what I do is when I copy the formula and press enter on the square below, it was smart. It gave me -2. Now, what did it really type in the square for me? It didn't type A2 minus 12. If you click on it, you could see what did it type? A3 minus 12. Sierra. Oh. Sorry. What's that? Say it again. Then you have to paste it or press enter. One of the two. It didn't do. Try copying again. Try copying again. Got it? Okay, sorry. So, enter, right? And so what you can do is you could copy this formula all the way down the column. Here, watch this, guys. I'm going to highlight both of these because I have them both now. And if I put, you see what shape my cursor is now? It's like a cross, a white cross. If you go into the corner, you ought to be able to get it to make a black cross. You see how it changes from a white cross to... If you ever get it to be a black cross, Excel is telling you, hey, I think you're ready to copy a formula, and I think I know what you want. So now I'm going to press my click. I'm going to click on it, and I'm going to drag. Oh, that didn't work. We'll try again. I'm going to drag down here. Now, if you don't like that, if you say, hey, I can't get that to work, one nice computer key I think everyone should know about is Control-Z. Do you guys know what Control-Z does? Control-Z is an undo button. You can undo everything you did. You can press it as many times as you want. But what I could do is I could copy the formula down, and if I press enter, it ought to just do the whole thing for me. If you're not following totally, we're going to have about 5 minutes of recess in a minute where we're going to let you play with Excel and try to learn some things about it. This is not the most important exercise we've ever done. The statistics is more important than Excel, but it was right here and I said I have to try. Let me show you one more thing. Ready? You did not? Okay. Well, we'll take a look. Hey, these numbers here, after I have them, can you guys tell me what I'm supposed to do with these? Supposed to square them, right? Okay. I'm going to go to the next column. What'll I label it? Maybe I'll say, okay, square them. Just so I can remind myself what I did. Right? What am I going to type here? Equals. Equals what? Well, take that -3, so that would be B2. I'm going to click on B2, and it's going to type B2. And do you guys know how to do exponents in the world of computers? That little symbol, yeah, it's called a caret. It kind of looks like a hat. Where is it on our keyboard? For me, it's Shift-6. That symbol. So I want to do caret 2. Enter. So it squared it. Now what do you think I'm going to do? Yeah, I'm going to copy this or somehow. Another way to do copy is Control-C. I mean, there's a lot of shortcuts that you learn over the years. But somehow, you know, maybe you right-click and click on copy or whatever, and then you want to highlight everywhere you want to copy it, and just press Enter, and it'll copy it all the way down. So now it's squaring all of those. It takes some work. Tell me what I'm supposed to do next. I know you may or may not be there. Tell me what I'm supposed to do next. I do want to divide eventually, but what do I have to do first? I've got to take all those numbers and do what? All right, ready? So here's how I'm going to do it. Equals. When you add things up, you get what's called a sum, right? Remember that was a big sigma? If you start typing the word sum, look what Excel does. It starts guessing what it thinks you mean. And do you see how this says sum in blue? I'm going to click on it. If I click on that, it gives me a capital sum, because that's like a command, and then it has an open parentheses. And it's asking me, what is it that you want to add? So now I'm going to highlight all the cells I want to add. And what it types for me when I highlight those, it says C2 colon C9. Yeah, I highlighted what it was I wanted to add. And then what am I going to do? I'm going to close the parentheses and press Enter. 28. Okay, we're getting there. Here I go. Equals. Well, I want to take this, C10, right, and divide by what? Well, I needed n minus 1. So I guess I'll divide by 4, right? And there's my 7. Oh, no, it wasn't 4. What was it? I'm sorry. What did we divide by? 7. Thank you. And then we take the square root of that. So here's my last one. Equals SQRT is a shorthand function for square root. If you double-click it, there it is. What do I want the square root of? I'm going to click it, the cell, close it, enter. Okay. Wow. Now, I'm about to put you on recess, but I'm going to show you guys one more thing. SQRT is short for square root. I think it makes it all capitals when you double-click it, yeah. Ashley? Okay, we gotta wait for recess. Give me 1 second. It's almost recess because, first of all, you guys are not going to become computer programmers by the end of this class. That's not my goal. I just wanted to show you a little bit of what Excel can do. And I want to let you play with it a little bit today. But the other thing is I think this kind of shows you what is behind the standard deviation. It's telling you how spread out the data is. You know, I'd like to go to Excel Stat here. You guys learned how to do this, right? Here, I have to launch mine. So, of course, when I launch mine, if I remember right, it gave me another blank worksheet. And I don't want the blank worksheet. I want to do Excel Stat on this one. Okay, so here's all my different things I can do. And so what I'd like to do is I'd like to work on one variable statistics, okay? And so right here where it says descriptive statistics, I'm going to click on that. Do you guys have that button or is yours a little different? Do you guys have descriptive statistics? Descriptive data?
It's underneath describing data.
Describing data. Okay. Well, what I'm going to try is it says, hey, where is your data? We have quantitative data because we have numbers. And the original data, I'm going to highlight right here. Let's see how that goes. So I want to highlight these numbers. And it says, sheet 1, this says A2 to A9. Oh, wait a minute. The way I highlighted it, I did not include the sample label, right? Now, if you just did column A, you want to leave that checked. But I don't want to leave. See, the way I highlighted this, I'm going to uncheck the sample label. Because I don't have a label in my selection. And I'll press OK.
Where do you find the descriptive data?
It's under descriptive, it's something different because I have the free one. Okay, guys, so it gave me a whole bunch of statistics. We did this yesterday on the calculator. We did one variable statistics, and it gave me a whole bunch. You guys remember that? Well, look what it gave me. It gave me the minimum, the maximum, the median and mean are both 12. And down below, what do you see? Let me zoom in on that so you can see a little better. Okay, let's scroll down here. There they are. There's my standard deviation of 2. You guys see that? Right above it, I want to point out it says variance. The variance is 4. Okay? Because the variance is what you get before you take the square root. Okay? So that's always just the standard deviation is the square root of the variance. Okay? So I guess what I'd like to do is kind of let you play for about 5 minutes here. I'm going to come around, I'm going to collect any homework that you guys have, or at least maybe chat for a little bit. And I'm also going to let you guys try to see, can you come up with the standard deviation of the third data set, which is right here, 2, 12, 12, 16, 18. You can use Excel. I guess you could work by hand. Whatever you think you're going to get more out of. All right? I think to play with this for a little bit on the computer is a good exercise. So I'm going to pause and let you guys do that for a little bit. You guys are telling me you worked out data set C, and you got the square root of 38. So is the standard deviation more or less for data set C than the other ones? It's more, because the square root of 38 is more than 6, right? Square root of 36 is... And so actually, you know, if I go to Excel, I mean, one way to do this... Here, I could do this. I could go up here, and I could just replace this data. right? Like if I press delete, it's gone. That's kind of weird. And if I just typed in the, what are the 5 data points? We had 2, 12, and 12. And then we had 16 and 18, right? That's interesting. And if I just got rid of these. Oh, but there is one other thing I did wrong. And that is, remember I divided by 7 the first time? What do I have to divide by this time? 4. And so, yeah, we get something a little more than 6. You guys got 6.2? Something like that? Okay. So this data is the most spread out of the 3 data sets, is what that's telling you. Okay? I want to go back to Excel Stat for a second. And I want to go down to this little picture down here. I don't know if you've seen this yet. It's called a box plot. And there we have my box plot. I think I'll zoom out a little bit actually this time so we can see it a little better. That's what's called a box plot. And as I move into the box plot, it's funny, on my calendar, my course calendar, I'm actually moving to the next section of Chapter 3. I told you, Chapter 3 goes very quickly. Look, yesterday we did measures of center. Today we started talking about measures of variation. We also today want to talk about measures of relative standing and box plots. And so I want to show you what these things are. Okay? So, if I go to the notes, I think that's where I want to start. We were talking about standard deviation. That's the distance away from the mean. And another measure of variation is called variance. And that's just S squared. Okay? So sometimes you'll hear people talk about the variance, and sometimes you'll hear them talk about the standard deviation. In either case, we're basically saying, hey, how much is this data spread out? Well, if you take a look at the Excel sheet, maybe I should go back to the first original worksheet. So in this data set, guys, what would be the variance of this data set? 38. It's the S squared. It's what you get before you take the square root. You guys follow that? So these are numbers. And again, 0 would mean there's no variation. Okay?